For planetary orbit, the point that is closest to the Sun is called perihelion, and the point that is farthest from the Sun is called aphelion. The Earth's distance from the Sun is 147 million kilometers at perihelion and 153 million kilometers at aphelion. Find the equation of the Earth's orbit. We know that the orbit of the Earth around the Sun is an ellipse, and so it has the equation x squared over a number squared plus y squared over a number squared equals 1. From this figure, we see that the major axis is on the horizontal axis, and so a squared has to be below x squared because a is always greater than b. And so we have x squared over a squared plus y squared over b squared equals 1. To find the equation of the ellipse is to find a and b. If we take 147 million kilometers plus 153 million kilometers, then we would end up with 2a. And this is the distance of the major axis. 147 plus 153 is 300. 300 equals 2a, so a equals 300 divided by 2, which is 150. Be careful here. This is not just a equals 150, but 150 millions. And if a is 150 million, then a squared equals 150 million squared. And 150 million squared, first we take 150 and then we square it to get 22500. And then because we have 6 zeros here, squared it would give us 12 zeros. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. In scientific number, this is 2.25 times. If we were to place the decimal at this 2, then there are 16 digits after that. And so this is 2.25 times 10 to the 16th power. It is true that there is the relationship between a, b, and c, where c squared equals a squared minus b squared. But we only have a here. We don't have c and b. However, the Earth is orbiting around the Sun, so the Sun is basically one of the foci. And so the Sun is located at negative c, 0, if we were to use the y-axis and put it in the center. Using the properties of aphelion and perihelion, we see that a minus negative c is 153 million kilometers, and negative c minus negative a is 147 million kilometers. From here, we should be able to solve the system of equation and find c. Simplifying this, we have a plus c equals 153, a minus c equals 147. And we don't want to add the 2 because if we add the 2 equations, we will end up with 2a equals 300. We will multiply one equation by negative to obtain an equivalent system of equation. A plus c equals 153, negative a plus c equals negative 147. We then add the 2 equations to obtain 2c equals 6, c equals 3. 3 million kilometers, not just 3 kilometers. Now that we have c, We then use the equation c squared equals a squared minus b squared to find b. We have c, which is 3 millions. We must be careful when we square the number here. 3 millions is 3 times 10 to the 6 zeros, and we square this. A, we found it. It was 150 million, and we square this minus b squared. We then move b squared to the left-hand side. The right-hand side is now 150 times 10 to the 6th power squared minus 3 times 10 to the 6th power squared. We then evaluate the right-hand side to obtain b squared equals 22,491 times 10 to the 12th power. In scientific notation, b squared is 2.2491 times. We have 4 more zeros to 10 to the 12, which is now 10 to the 16. And so we found b squared. We also have a squared, and that's all we need to write the equation of this ellipse. The equation of the Earth orbit is therefore x squared over a squared, but a squared is 2.25 times 10 to the 16 plus y squared over b squared, but b squared is 2.2491 times 10 to the 6 equals 1.